Good afternoon and welcome. This is grade 9 coding. It is the 20th of July and we are going to be looking at while loops with the farmer. These are conditional loops, so we'll have a look at them. We will aim to do puzzles 7 to 13, but again, I'm not limited to that. I can adjust the schedule as I see fit. Some things we spend more time on because it's more important. Some things we spend less time on because it's easier. So it all just depends, right? If you don't know me yet, perhaps you're watching on the YouTube channel. My name is Mr. Paul de Klerk and I am the senior phase coding teacher for STEM Digital School. And I'm also the YouTube administrator and EdTech systems trainer for Africa Team Geek. So welcome here. And I hope that you enjoy these lessons with me. So we've been doing this for quite some time now. We have advanced quite a bit. We are following Code.org's Express course. So Code.org is really good at explaining to you what to do and how to do it, but they don't always jump into the minute details of each puzzle, explaining to you why exactly it has to happen the way that it does. So that's what I'm here. I'm trying to give you a little bit of a deeper understanding and a little bit more information than just what you see in front of you, because my aim is that when you leave here, you don't only know how to solve the puzzles on Code.org, but if you were to jump onto any other platform, there are some great ones out there. My son is on one that we paid for him to use for the year. If you jump onto that and you encounter coding languages like Python or PHP or any other coding languages that these platforms offer, you'll still be able to help yourself. You'll still be able to go ahead and understand, at least draw similarities between what you learned on Code.org, which is based on JavaScript, and what those languages and those puzzles are requesting from you. Okay, so JavaScript is the most widely and popularly used coding language in the world. It is also one of the most highest paid coding languages for people in South Africa. But then you need to be a specialist. So you can't just finish one Code.org Express course and then go and market yourself as a JavaScript coder. It doesn't work that way. Coding specialists who specialize in JavaScript, who can solve problems with JavaScript that other people cannot do with using other coding languages, they earn big money. Now, for you to get to that point, you need to spend time behind the screen and code, right? I'll say it again. I've said it before, and I'll say it 1,000 times in the future. You need to sit behind the screen and code. And you need to also take especially these free play puzzles that you find on Code.org and do them. Because that not only tests your deep foundational understanding of the coding language, but it pushes your imagination. It helps you to think in different ways how to solve certain problems that you might encounter. Right, so let's get going here. This is a quote from Jeff Bezos, the Amazon founder and CEO, or he is the founder of Amazon and the CEO as well. And I couldn't find information on whether he's a coder or not, but the mentality that he's speaking about here definitely applies to coding. And it says, I knew that if I tried and failed, I would not regret it. I wouldn't regret that. But I knew the one thing I might regret is not trying. And that's the way I live my life. I take on things and I try. When I started to learn coding, when I started to learn how to create websites, that's what I use coding for, by the way. I didn't know anything about that. I didn't know anything about how websites function, how to design. And up to this day, I'm not a particularly good designer. I'm not ashamed to say that. There are people who are awesome designers. So I have learned to collaborate with people that are better than I am in certain things. So I knew at that stage that there was a high possibility and probability of me not being able to do what I set out to do. And I was right. In the beginning, my first 3 or 4 websites sucked. They weren't user-friendly. The user experience wasn't nice. It didn't work well on a mobile and on a desktop. I could code it either to work well on a cell phone or to work well on a computer, not on both. There were many, many issues that I had in the beginning. Buttons would just break. Stuff that would work today, tomorrow wouldn't work. And there were database communication issues and all of that. But it wasn't a failure because I didn't quit. In my definition of a failure is you only fail the moment you stop trying. The moment you quit, the moment you give up, that's the moment you fail. As long as you keep on going, you haven't failed, you're just learning, right? So I could have stopped there after those first 3 sites and it would have been a failure. And even if I did choose that route, I still wouldn't have regretted it because I tried. I was there, I did it. And I could make an informed decision, right? So I will also always regret more not having tried than having tried and decided, okay, this is not for me. So that is very important in coding because that tenacity to continue, that talent to face adversity, it's not only a talent, it's like a muscle that you can exercise, right? That is really important in what we do. Awesome. So let us have a look at this. Terms to know: conditionals, if-else logic statements that change the way code is executed. In other words, you put the code on the workspace, you let it execute, it will execute in a certain way. If we are not using conditionals, it's going to try and execute. Doesn't matter what the restrictions on the play area is, doesn't matter what the restrictions on anything is. It's going to try and execute that code. Once you put it in a conditional, now it's going to change the way that it's executed. Now, instead of just blindly executing blocks of code, you might check before you execute. And if you find a certain condition to be true, then you might execute. If you find that condition to be false, you might execute something else, right? So there's that big change that we have there, that shift that comes about where we can use the same blocks of code, but we can execute it differently, which is very, very powerful. Now, where it really becomes powerful, this is where you're going to see it, is in a conditional loop. So conditional loops repeats that execute while a condition is true or until a condition has been met. So a while loop, as they call it on this platform, is going to execute as long as something is in a certain condition. Example, while there are pumpkins, we want you to move forward. So we're saying, as long as there is a pumpkin on the play area, you need to move forward. The other one says, until a condition has been met. So there you could have something like, until there are pumpkins, meaning we're going to move forward until we are on a space where there is a pumpkin, then we will stop because that condition has now been met, so the loop will finish, it will self-terminate. Okay, so this conditional loop idea and concept is very, very powerful. It's something that we will definitely use, especially when you look at game design and the object tracking variation or logic sphere, logical sphere of coding, if you want to call it that. Right, so I think we can jump into that. We're doing while loops with the farmer. So once we get on the coding platform, I'm going to share the link with you. We will review puzzle 6. You know that I believe, and if you don't know it yet, I'll tell it to you now. I believe, and it's been stated by research, that repetition is the mother of all learning. So the more we get to do the same thing, albeit in different ways or different applications, that's how we're going to learn. And it gives you time to access the link, right? So if you're new here, you just click on that link. It'll open in a Google browser like this. And then you can, on the right hand top corner, there's an X to close, a little line to minimize, and in between you have these 2 boxes that says restore down. If you click on that, it's going to make your Google browser smaller. If you're using Explorer or you're using Safari on a Mac, it's okay. I'm talking about your web browser. So you can make it a bit smaller, and then you can also make the zoom screen smaller. You can have the 2 side by side, code on the one and watch me on the other one. Okay. So every Monday I'm going to do this. I have to run through this entire thing. This is what's known as a GUI, or a graphical user interface. And what that means is it's the platform or the interface that we use to interact or engage with the software or the computer. So if you think about it, if the computer has to talk between the processor and the hard drive, right? If there's communication that needs to happen. The computer doesn't need text that looks like our alphabet. It doesn't need orange and blue and pink blocks or green trees or everything laid out nicely. It just needs ones and zeros, binary code. It's a computer. We as people, we need these things. We as humans, we don't want to see just ones and zeros. Perhaps somebody wants to. I don't. To translate that into information that my brain can process will take longer than it will take me just to use the platform. So for that purpose, the graphical user interface, or the GUI, was designed. And what that basically means is we have pictures, we have little indications with regards to the hand. You can see it's a pointer, and once it's on something that I can click, excuse me, it changes into a hand. When it's text, you can see it changes. I'm specifically talking about the mouse pointer now. Here you can see the blocks have nice shapes and colors. They have drop downs with arrows. Okay, so all of those things, that is what it is when I speak about the graphical user interface. It's how we as people interface with the computer, because we do not speak binary. Okay, our processors are not designed to process that information in the same way, right? So if you keep the link open that I've just shared to you, you can open it in your Google browser or any web browser. You can copy it there from the address bar. You can see at the top there, I've highlighted it so that I can copy it. Then you can actually save that onto a text editing platform such as Word or Google Documents or Notepad or whatever it is that where you do your text editing, right? You can save that and then you can come back to this later. You don't have to be in the lesson with us to have access to this. Or you can just keep your browser open after the Zoom lesson. That's also fine. You click here, you'll access all the other lessons that we've done so far so that you can catch up if you are behind. These are the puzzles that belong to this lesson. The green ones we've done. The unhighlighted ones we haven't done. The diamonds are videos. We don't watch them here, but you can watch them on your own. Here we have the instructions. So code.org is particularly good at telling you how and what to do. So they'll tell you, okay, you need to move this one from here to there, and you need to use a move forward block to do that. What it doesn't do is explain why. Okay, so you see here, that is going to show you the how. The videos, they do show a little bit of a why, but not in as much detail. Here you have the play area where you will see the magic happen. Here's your toolbox with all the blocks that you use to code on the workspace, and on the workspace is where you will create the actual code that you will see happen there. There's a run button connected to the when run block. When you click here, any code that's connected to that will actually start running. It has to be connected like that. If it's unconnected, you will see it's unhighlighted and it is shaded out, and that code will not run. Perfect, so I think we're done. Now what we are going to do is we need to read this. I don't know how much dirt is in this pile. Help the farmer remove this entire pile using the while loop or a while loop. So here we have a while loop, and what that says is while there is a pile. So we have a remove one action block. Okay, I'm going to move this down. The remove one action block is going to remove one shovel full from that pile. Now we don't know how many shovelfuls there are, so we cannot say, okay, repeat remove one 5 times, because that will only work if there are 5 shovelfuls. But what if there are 6? Or what if there are 3 and we're trying to remove dirt where there aren't any for us to remove? We're going to be digging holes, which is also not what we want. Okay, so what we have to do here is we're going to first move so that we can be on top of that pile. Then we're going to say while there is a pile, we want you to remove 1. And you can see you can change this. So this can also be while there is a path ahead, we want you to move forward. Okay. So as long as this condition is true, do this. As soon as this condition is not true anymore, stop doing this. And there was only 1. No, there's 10. Look at that. So we got to remove all of that. Beautiful. So my question to you is, can we move on? Type it in the chat box for me if you're ready for us to continue on to the next puzzle. Great, I have a yes in the chat box, so we can move on. Help me remove all of this dirt. We only have 5 blocks. So the way we want to do this is to say move forward and remove 1. We don't know how much we have there, so that's a bit of a problem. So let's change that to this and then say remove 1. Now we've tested this sequence and it works for that pile. So it stands to reason if it worked for the first pile, it should work for all the other piles. But we only have 1 block left. So how are we going to do this 1, 2, 3, 4, 5 times? Because we cannot do this. Because now we are already over our block limit. So how will we do this 5 times? What do we do? Yes, we're going to nest this entire sequence in there. We're going to do that 5 times. So what I want you to pay attention to here is the following. You can put a statement, a sequence, a loop, a nested loop, a conditional repeat, a variable, a function, anything into a repeat block. You can even put one repeat inside another repeat inside a repeat. So let's say there was a turn that had to happen here or something, or there. Right, so you can see, there it wouldn't matter, but here, you can see you can put anything inside a loop. So what we call it when we put one loop inside another one is we nest that loop. This is obviously going to happen 5 times. So we take the solution for the first pile. We apply the solution 5 times because there are 5 spaces that have piles of dirt on them. And we're good to go. Does that make sense to you? Can I move on? There's a yes. Okay, I'm just going to add this into the chat box there. Look at all of those holes. Each one needs a different amount of dirt. Can you use the while loop to easily fill them all? And that is a yes. But before we can, we need to move over them. So we're going to move 1. We're going to say, while there is a hole, fill 1. I'm going to test that and see that it works. Then we obviously need to turn right. We need to move forward again. And then we need to do this again. We can test that. Now we're going to add that, and we're going to see that, okay, we've now done 1, 2. So what this actually means is we're going to do 1, 2, 3, 4, 5, 6. But we are filling 2 holes each time this sequence is run. So if we want that to happen 6 times, we take 2, 6 divide by 2 gives us 3. Because if you take 2 times 3, you get 6, and there are 6 holes that we have to do, and each time this sequence is run, 2 holes are getting filled up. And so we just need to repeat that because we already found the solution, not only for a single hole, but for that little line with 2 holes in them. And you'll see sometimes the amount of dirt needed changes. So now we have 3, 1, 2, 5, 4 something. Now we have 4, 6. Run it again. Now it's 4, 8. Run it again. It's 4, 8 again. Again, now it's 4, 7. So you see, you need to find a way to solve this and that. You could have just used a full 3, full 1, full 2, full 5, full 4, and then used this while. But imagine how much code you would have used. So in my opinion, whether you know how many shovelfuls you have to place, or whether you don't, to use the while loop is going to save you a lot of time and effort. Does this one make sense to you? Can we move on? Okay. I would have liked you to give me an idea here, but I don't see that happening. So let's just go ahead. So what we're going to do here is we need to move from there to there, and then to there, then to there, then to there. But there isn't a pattern. Here we're moving 1, 2, 3, 4, 5, 6, 7. There we're moving 1, 2, 3, 4, 5. There we're moving 1, 2, 3, 4, 5, 6. Here we're moving 1, 2. So we can't really just use this repeat by number, and we only have one of them to use. And we also only have one move forward. So you can't really say move forward until move forward 5 times, then turn left, then move forward this many times, then turn left. So now we're going to use a while loop for that. We're going to say, while there is a path ahead, we want you to move forward. As soon as there isn't a path anymore, we want you to turn left. And while you're at it, just fill 1 because you are standing on top of the pile at the end of each path that you will be walking on. Now you can test this for this first row here at the bottom, and you can see those little lines. It looks like the Wi-Fi symbol. That is how the farmer is busy checking what is in front of her. Right, so there we've done that one. So that works beautifully. We can see that that was the solution that we were looking for. It worked for this bottom path. So now what we need to do is we need to follow this path, this one, and this one. So this is 1, 2, 3, 4 times. So all we're going to do is say repeat 4. So look at that. As I showed you earlier, you can actually have a repeat of numbers inside a nested loop, or you can have the while loop inside a repeat of numbers. And there we are now. You're starting to get it. That's good. I like it that you're starting to get it. That's what I said to you guys. If you at first start here and you are behind, maybe you didn't start with all the others, just keep at it. It's going to start making sense the more you do it. It's the only way to learn these things. Great. That's awesome news. I'm very happy about that. Okay. I just want to, no, I don't want to skip that. I want to go back to that one where we just was there. Okay, so this one we could do in this way because you can see that the holes are at the end of each path, right? So that helps us a lot with our pattern, to see the pattern. Okay, the moment you see this pattern, it becomes a lot easier because it helps you to understand which loop you have to use, right? So now we can skip on to this one. This one's a bit more tricky, but still a lot of fun to do. So we're ready, we're not afraid. All right, let's have a look at this. Now this one, apply the same mentality that you just used in the previous one. The only difference is now instead of having 1 at the end of each path, you have an unknown number. So check, this is a path that finishes. There's another path that finishes. There's another path that finishes. There's one that finishes. There's one that finishes. There's one that finishes. So what we're going to do is we want to move forward while there is a path ahead, and when there isn't a path ahead anymore, we want to turn right. Okay, now we want to do something else. Instead of just repeating back to that or just saying full 1, because we have multiple ones here, this one has 2, these ones we don't know, we're going to also say while there is a hole, full 1. So now we're using a conditional for the positioning and the movement, and we are using a conditional for completing the tasks. So if we run this, you see there we have 4, and there we go. Now whether you fill the hole first, let me just show this to you, and then turn right, or whether you turn right and then fill the hole is up to you. Doesn't make a difference in the way that the code is executed, doesn't make a difference in your block code. So now we have the solution for the first path from there to there. This is the solution. Now we have 1, 2, 3, 4, 5, 6 paths. So all we need to do is take this solution where we've just figured it out for one path and make it happen 6 times for 6 paths. There you go. And there it seems to be doing its thing and working correctly. Awesome. So I'm just going to talk through this code one more time. If you hear some funny noises in the background, there are people working here on the section of our house, and my little dog is a very small dog, but she thinks she's a monster, a wolf or something. So whenever anyone moves outside, she goes crazy and she makes all these funny sounds as if she's going to protect me from a leaf blowing. There you hear her going, but she'll keep quiet in a minute. So just excuse that. You know, animals, they don't always understand things, and she's just trying to do her job. Although the person walking outside has a ladder in his hands, if he just points it towards her, she's going to run away. But while she's behind the locked door, she's very brave. Okay, that's enough said. So what we're going to do, or just what we did here, was we said, okay, we need to move forward, obviously, but we're not going to move forward the same amount of times every time. They were moving once, twice, 3 times, 1, 2, 3, 4 times, 1, 2, 3, 4, 5, 6 times, 1, 2, 3, 4, 5, 6 times. Okay. So it's very difficult to say, okay, we're going to place this move forward into a specific repeat block. We can't do that. So what we do to compensate for that is we say, okay, while there is a path, we want you to move forward. So what that means is whether the path is 1 long, whether it's 6 long, whether it's 3 long, as long as there is a beginning point and an ending point for that path, it's going to work, okay? So that is what we said here. Said, okay, we want you to move forward as long as you can move forward. While there is a path for you to move forward on, yes, we want you to move forward. Then we said the same thing. Now we have a hole here. We don't know how many shovelfuls it needs to be filled up. This one needs 1. This one we don't know. That one needs 2. This one we don't know. This one needs 1. So the same logic applies. We're going to say as long as there is a hole, just fill in 1 shovel and keep doing that until the hole is full. So once this condition is not true, it is now false, it will stop. And then after you've done that, turn right and do that 6 times. Okay, so that part is easy. Great stuff. There we go. I think we can continue now. Right, so here we have while loops with the farmer. This time it's this way, and we are going to be picking up these piles. You are not interrupting. If you want to ask a question, please do. If it'll be easy for you, Tabelo, and you are comfortable with that, I can unmute you as well, and you can speak to me over the microphone, or you can just type in the chat box your question. Job opportunities does coding give you? Okay, that's the question that you're asking. What job opportunities does coding give you? So the first and foremost thing is you can, if you know how to code at this stage, right? You learn how to code now. You can work the way that I've been working for the last 7 years as a freelance developer. So then you can choose your media. You can either be an app developer or game developer, or like I am, a web developer, right? So an app developer will develop apps, a game developer will develop games, and a web developer develops software that is being used on the internet. But working as a freelancer means that you do not work for a company. You're basically doing your own thing, and people hire you as they need you. So you need to advertise your skills, and you need to be in charge of your contracts with people, all of those things, right? Another way to go about that is if you actually do a few courses, then just give me a second, please. If you go and you do a few courses, then you can get work at a company, and the company will then specialize in web development, app development, game development, or just normal software engineering, okay? And then the final thing is if you actually start to study computer sciences at a university, then you can work for big companies like Google and Microsoft. Now, I'm not saying that everyone that works for Google and Microsoft studied computer sciences, but that is a very good way to do that. So if you study computer sciences at a university, then you can actually create software programs. So everything that you're using on your computer, Windows, Word, PowerPoint, the internet browser, absolutely everything has computer code behind it. So that you can just imagine what you can do using computer code. So there's software developing, app developing, game developing, and then also web developing. Those are the four broader terms, and then they specialize into many different things. There's also server-side development where you work on servers that operate and maintain data between companies that work internationally. So there's a lot of things that you can do with regards to that. Okay. I hope that answers your question, and it's a good question. So I'm glad that you've asked it. Right, so let's look at this puzzle. We have about 10 minutes left. So this one says, or it's very similar. We're going to change our position to be in line with this so that we can pick up that pile, right? And luckily for us, again, the piles are all at the end of each pathway. Okay, so we're going to move forward until we reach the end, which says while path ahead, move forward. And then instead of filling one, this time we're going to remove one. Now we don't need to put this one into a, excuse me, we don't have to put this one into a while loop because we can see each one has only one, right? So you can then turn left. Either you can turn left before or after you've removed. It's not going to make a difference. Just remember that it happens in sequence. So if you look, this is going to remove, then turn. If we change that around, we're going to turn and then remove. So it's just important to understand that this happens in a sequence, but because of the way that this puzzle is structured, it doesn't make a difference. The sequence doesn't make a difference. So now we have the solution for that, and we can see that this one, and this one is the same. So we want to repeat that solution 3 times. And we run it. And there you can see those little Wi-Fi lines. So there you can see those little Wi-Fi lines. Shows you what we had there. It shows you that she's checking whether there is a path in front of her. Excuse me. So that's the conditional being acted upon. Okay, remember we said that conditionals forces the code to be executed in a different way. So she checks the conditions before she executes the code. Not her, the code does that, tells her to do that. If that makes sense. Okay, I think this is going to be our last one, and then the next one's going to be your homework for this, for today. Okay, so what we have here is, again, we have a pile there that we know it has 1. So remove 1 will work. There we have a pile, and we don't know how much is in there or how many times we have to remove to get it gone. Okay, so remove 1 alone will not work there. We need to make another plan. And over there we have one that's 3 piles. So we can either put 3 remove 1s, or we must repeat remove 1 3 times, or we must make another plan. So in my opinion, I think what we should do is say, okay, before we start working on that, how do we get from there to there? We do that by moving forward as long as there is a path ahead. Great. So that seems to work. Then we obviously want to turn left. Now here we want to move again. So in my opinion, I'm going to say again, while there is a path ahead, move forward. Okay. So now I'm first figuring out how to move about. Then I'll figure out how to remove the pile. Okay, and that works. So now the next thing we need to do is we need to turn right so that we're facing this way. So now we're moving up to there, facing this, and now we can see the pattern. This and this, if you follow my mouse pointer, so from there to there, and again from there to there, is going to have the exact same pattern. So all we need to do is repeat that entire pattern, okay? But before we do that, let's just build in how to remove those piles. So this is going to happen after the first path is finished. So there we're going to say, while there is a pile, remove one. Now there's only one here. So if we only use the removed pile, that would have been fine. But now we know there's a pattern, which means we want to use this code for the rest as well. So now we code this in here to make sure that even though it's unnecessary for this, we can just use it there and there again. So we're going to repeat this a few times. 1, 2, 3 times, to be exact. And that works well. Perfect. So I'm going to share this with you. This puzzle 13 is your homework. You can share it to me. You're not going to code anything. You need to get the answer, right? So select the answer here and tell me which is the right one. Actually, yeah, do it that way. Okay. And then just do me a favor, if you do send me an email and you've screenshotted that, just tell me what grade you're from, please. As I said, I teach the entire senior phase. I'm involved in the other grades as well. You're welcome, Tabelo. If you're interested in coding, this is just the beginning. You should stay with us. You'll see it becomes very interesting later on, okay? So if you could do that, you could screenshot that. We're going to continue with harvesting with conditionals tomorrow. So we're going to be practicing some more conditional repeats. And then you can please just send me the screenshot of your homework here. I'll give you feedback if I need to. If the solution is right, I'm not going to give you any feedback. I'll just mention in the lesson that, okay, cool, I've received an email from this and this, and well done. Okay, so there's my email address. You can find us on these social media platforms as well as on YouTube if you search for Africa Team Geeks. Have a great day, guys. I'll see you again tomorrow. And I see we have 2 participants. So if you have friends that you think might enjoy this, you can invite them as well. All right. See you again. Bye-bye.